Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn differential calculus under the basic mathematics. And remember that one thing, in this differential calculus there will be two physical quantities, one will be x and another one will be y. If I am taking x is the independent quantity, then y will be the dependent quantity, and here in terms of function we can write y equal to fx. In maths you will learn in a detail. Okay, so let's go through the video and let's learn all these basic things and all that. So see here the differential calculus, and see, the purpose of differential calculus is to study the amount of variation in a physical quantity y with respect to another physical quantity x. So as I have told you, this x is the independent and this y is the dependent quantity. Here we are learning x and y, but in physics we will see like a position, time. Time will be the independent, position will be dependent. Similarly, velocity, time will be independent, velocity will be the dependent. Similarly, acceleration time will be the independent and acceleration will be the dependent. So like that, any two physical quantities can be involved in physics here, okay? But we are going to learn in a general form, that's why we have taken x and y, okay? So after that, see, first one we are going to see what? Average rate of change. What is this average rate of change? So see here, it is defined as the rate of change of y with respect to x in the interval x1 comma x2 as shown in figure. So remember that students, this average change is always applicable for some interval. Especially in physics there will be the time interval. What I am telling? Time interval. But here we are learning in terms of x1 and x2. So what I am going to do here, see, here I have taken, this is, let's take x-axis, and here I have taken here, let's take here, this is the y-axis. Is it? And here I have taken here the one graph. Let's take like this is given here, and let's take this function is given here, y equal to fx. Okay, it can be y equal to x square, y equal to x cube, y equal to root x, anything. Now we have taken general one. So what I want to know, I want to see the average rate of change in some interval. Okay, so here let's take here I have taken, let's take, this is the point x1, and here I have taken what? This is the point x2. And corresponding to this x1, x2, independent one, we have taken here this one here. Let's take on the y-axis y1, and what will happen that here? Let's take on the y-axis, this is the y2. Okay, and after that, here, this one we have taken here. So students, if I talk about here, let's take here, I have drawn here one more perpendicular is there, no? And let's take, I have taken here m. So what is this here? Average rate of change of y with respect to x is given by here. It is given by, let's take here, this is point A, this is point B. So can you tell me this length? This length is given here, y2 minus y1, I have written here the delta y. Similarly, this length, how much here? This length is the x2 minus x1, I have written here delta x. Okay, so students, this average rate of change of y with respect to x in the interval x1 comma x2 is given by delta y by delta x. Very easy. What is this? Delta y by delta x. That means what we can tell? Perpendicular by hypotenuse. Okay. Similarly, this average rate between A and B can also be given as like this. If I draw here one line here, straight line, see this line here. Now see, if I draw here this line here. So here you can see one triangle. What is that triangle? You can see A and B. And let's take this angle is theta. What is the angle theta? So you know very well, delta y by delta x means opposite by adjacent means what? Tan theta. Okay. So if in case any time we want to calculate the average rate of change between the 2 points, then this average rate of change is also given by, you have to just connect both these points by the straight line and the slope of that line. The slope of that line will give us what? The average rate of change. Okay. So even what this is called, this tan theta is also called slope. Is it? So I hope so students, this average rate of change is the very clear. Okay. Now after that, what we are going to see? The next one. Now average rate of change is there. Now we will solve you. See. Question. An object moves from x1 equal to 1 meter to x2 equal to 9 meter in time interval 1 second to 3 seconds. Calculate average rate of change of y with respect to x. Some time interval should be always there. Okay. So what we can write here? Very easy. See. Average rate of change. Average rate of change. Here, which kind of quantity is there? We can tell time is the independent and x is the dependent. So here we can write here x2 minus x1 divided by t2 minus t1. Now, because these two physical quantities can change position to position. Means can change situation to situation. Okay. So x2 minus x1, how much is there? See, 9 minus 1. No? 9 minus 1, and here how much is there? 3 minus 1. So what this will become here anyhow? It will become here 8 by 2, and it will come here 4. Unit 4 meter per second. And you can see here, actually this is the unit of the speed. So what is the speed? Speed is nothing. It is just the rate of change of position with respect to time. Is it? So here position is changing with respect to time. So similarly, speed is there, velocity is there, acceleration is there, now all these things in physics. Is it? So I hope so. This is the very clear average rate of change. Now after that, see the next one. What is there? One more we have taken here. See, position of an object is given by this one. Now they have given the expression. Calculate average rate of change of x with respect to t in the time interval 1 second to 6 seconds. Okay. So again I'm writing here, see, this kind of things will repeat a lot in physics. So see here, average rate of change. Where to where? See here, 1 second to 6 seconds. What we know? x2 minus x1 by t2 minus t1. So x2 means final position. Final position at which time? 6 seconds. So I will write here x6 minus x1 by time interval 6 minus 1. Always we will calculate like this. Okay. So now students here, if I write here the x6, so what this will become here? See, 6 square, that means 36 plus 6 minus 1 minus x1. x1, what this will become here? See, 1 square plus 1 and here minus 1, and it will become here 5. Okay. So anyhow, what this will become here? You can see very well that 36 plus 6. 30 plus 6, how much here? 42. And 42 minus 1. So 41 minus here how much? 1 plus 1, 2. 2 minus 1, 1. So by 50 here. So anyhow, 40 by 5. So 40 by 5, how much it will come here? Again, it will come here 8 meter per second. Now, so what is this? This is the average rate of change. And for some of the students, for them, they are somewhat basic problem. So it does not mean like it is written here the 6x minus x by 5. Okay, this is wrong. It does not mean like 6x minus x by 5. No, here x value at which time? At t equal to 6 seconds. Okay, so don't do like this here. No, so I hope so this thing is very clear. We are doing the average rate of change here, always for some interval. Next one is students, here we are going to see the instantaneous rate of change. See here, what is this? See, it is defined as the rate of change of y with respect to x at a particular value of x, not interval and all that, at a specific position. Okay, so again see here, if I write here, see, this is x, no, this is y, and this is the origin. And again, I have taken here some graph like this, y equal to fx. Okay, so what will happen that here? Let's take for example here. At this point, I want to calculate the instantaneous rate of change. So what I will do here, one point is there. So through this, I will draw here one tangent. What I will draw here? I will draw here the one tangent. Does not mean like it should pass through the origin. Here it is passing maybe, but okay. And this angle. Let's take this angle is how much here? Theta. Anti-clockwise angle positive, clockwise angle negative. So what will happen that here? This instantaneous rate of change is given here. Remember that here. Let me change here the color because already blue is there now. So it is given by C, this limit. First let me write here the delta y by del x, and here this limit delta x tends to 0 here. Why I am telling delta x tends to 0? Because see, let me go to the back little bit to explain you. Here how many points are there? 2 points are there, A and B. So see, 2 points A and B is there. So if these 2 points A and B will come very close, see the delta x values keep on decreasing. So when these 2 points will become very close to each other, so these 2 points will become how many points? 1 point. And in this situation, this delta x value will be how much? Approximately 0. So to make 2 points as a single point, delta x is coming how much here? 0. That is called here the limit. Okay, that is called here the limit. That's why we have written delta x tends to 0. Okay, so what this will become here? This will become here dy by dx. Dy by, this is y, this is x. So what is this difference here? Dy by dx. How much is there? Tan theta. So here this will come here the tan theta. Okay, And remember that one more thing, now this thing we have done it, but remember that this tan theta is called what? This is called the slope of the line, slope tan theta. Now even in maths we learn as a small m. So remember that one thing, if in case this theta is greater than or equal to 0 and less than 90 degree, what will be there? This slope will be positive, slope positive. If in case this theta is the 90 degree, this slope will be undefined, not defined, because tan infinite, tan 90 how much? Infinite. Similarly, if in case this theta is greater than 90 and less than 180 degree, is it? So in this situation, what will happen that here? This slope will be negative. Okay, slope will be negative. Okay, and just see here. I will remove this equal sign here. So see here, depending upon the value of the theta, the slope can be positive, the slope can be undefined, and the slope can be negative. Here slope positive and here slope is the negative. Is it? I hope so. This is very clear. And see, under the remember what is given? See, graphical significance of differential calculus is the slope of the line. What is that? Slope of the line. Remember that here. And this slope is given by tan theta, and already I have told you the theta conditions when slope positive, when undefined, and when negative. Okay, great. Now students, let's see. After learning all these things, like in differential calculus, one physical quantity will change with respect to another physical quantity. Okay, so we are going to see some important formulae of differentiation. Okay, so let's see one by one. The first one we are going to see here. See, we are going to learn with respect to x. So see, d by dx of any constant. Now d by dx of any constant will be how much? Always how much here? 0 here. Okay, because see here, already I have told you, here we are going to write y as a function of x. Okay, so here we are going to see y with respect to x. This whatever value we are writing in the bracket, na, that is the value of the y. Na, dy by dx. Remember, so this is the value of y. Similarly, see, second one here, d by dx of x to the power n. This will be nx n minus 1. What will be there? Nx n minus 1. Okay. And if I talk about here are some examples for this. Let's take for example, if we are doing d by dx of x to the power 1. So here value of n how much? 1. That means we can write 1 into x to the power 1 minus 1, or we can tell 1 into x to the power 0, and what will come here? 1. Is it? Similarly, if I take one more example, is it? Let's take like this, d by dx of x square. So what this will become here? Like this, na? Value of n is 2, and I have used this formula. What this will come here? It will become here 2x. One more, because this formula is a very, very important in our physics. That's why we are doing this here. X cube. So again, n is 3. So 3 minus 1, what this will become here? It will become here the 3x square. And one more, last one, see. If in case it is given d by dx of root x. What is this? Root x. Root x means x to the power half. That means n value how much here? Half. So 1 by 2 x to the power 1 by 2 minus 1. So we can tell 1 by 2 x to the power minus 1 by 2. Or we can write here 1 by 2 x to the power 1 by 2. So what this will become here? 1 by 2 root x. Now, so all these examples are very, very important. That's why we have done here. Okay. Next one after that. See here the third one. If in case I am writing here, see, d by dx of log base ex. Okay, d by dx of log x base e. So in this situation, it will become here 1 by x. Okay. Similarly, if I write here the fourth one, let's take for example, d by dx of sin x. Okay. So d by dx of sin x will become what here? Cos x. Now, cos x. Next one, now these are the very, very basic formulas here. d by dx of cos x. d by dx of cos x, what this will become here? Minus sin x. Is it? Similarly, students here, see, if I am writing here, most of the time, very rarely only it will be used, but let's take for example, I have sin x, cos x, and let's take I have written here the tan x. So tan x, it will become here the sec square x. Now, sec square x. Similarly, if I go to the seventh one, d by dx of cot x. Cot x, it will become here minus of cosec square x. Okay, so at least this thing we should remember that here. Okay, after that we have calculated what are the things we have done. We have done the log, sine, cos, tan. Now we have calculated logarithmic, trigonometric, and we'll see exponential also. Let's take this one here. See, d by dx of if in case e to the power x. So what this will become here? It will become here as it is e to the power x. Is it? So I hope so. All these basic formulas are very clear to you. Oh yeah, okay. One more thing we'll do here. There used to be the chain rule. And remember that, students, this chain rule is applicable most of the time. Which kind of function? Maybe the function is logarithmic function. No? Maybe the function is the trigonometric function, or maybe the function is the exponential function. Most of the time this will be applicable here, chain rule. So what is the chain rule is there? According to this, see, if I write here, let's say for example, already we know it, no? But it's okay, see. If in case, let's take it is given here, d by dx of sine x square. D by dx of what? Sine x square. So what this will become here? First we will do the differentiation of sine x square. It will become here what? Cos x square. Okay. But after that we will again do the differentiation of x square. Okay. That means what this will become here? We can write here the cos x square, and this how much here? 2x. Or we can tell 2x cos x square. Is it? This is called the chain rule. Similarly, second one. If in case I am doing, let's take d by dx of cos root x. How much here? Cos root x. So differentiation of cos, how much we know? Minus sine. So we write here, see, minus sine root x, and again differentiation of root x. If instead of x anything is there, we have to differentiate again. Okay. So what this will become here? Minus sine root x, and differentiation of root x already we have done. What is this? 1 by 2 root x. And don't think so this root x we can't cancel. Okay, because this is in an angle, this is the separate here. Is it? So this is the chain rule is there. After that, students, if we see further here, let's take for example under the chain rule, trigonometry already we have covered. Let's take exponential, and here now I am going to do in terms of time. Let's take d by dt of e to the power t square. D by dt of how much? E to the power t square. So what this will become here? E to the power t square, and again we have to do the differentiation of t square. So what this will come here? E to the power t square into 2t. Is it? Similarly, fourth one. If in case it is given here, let's take for example d by dt of ln. Now log base is also called ln only, and it is given here, let's take ln t square. Is it? So you know differentiation of log x how much? 1 by x. Is it? So similarly in the same way it will become here 1 by t square, and again you have to differentiate this t square. So what this will become here? 1 by t square, differentiation of t square how much here? 2t. T and t will cancel, how much coming here? 2 by t. Is it? So students, in this way we have to apply the chain rule. Very, very important. Very, very important. Okay. Now after that some other basic properties are there for the, now some other properties. Let's take for example here the properties of differentiation. Properties. Okay. So what will happen there here? The first one, let's take for example, we are going to do this one here. Two functions are in a addition or subtraction, fx plus minus gx. So you know what will happen that here? We can just separate it very easily. D by dx of fx plus minus d by dx of gx. Okay, remember that. This is there. And next one is the very, very important. If in case it is given d by dx of two functions, let's take for example fx into gx is there. Okay, so what will happen that here? This will be the first function, this will be the second function. So what we can write here, students, here? First function, that means fx into differentiation of the second function, gx, plus second function into differentiation of which function? First function. Okay, so even I can write here, see, the first function, differentiation of second function, plus second function, differentiation of first function. See, if I talk about some examples, no? See here, if I talk about the example for that. So first example I have just taken d by dx of like this is here. Let's take for example, it is given sine x square minus it is given here, let's take here x cube. Is it? So we can make it into the two parts. What are the two parts are there? We can separate it. Say here d by dx will be always 2. Remember that. It will become here the sine x square and minus d by dx of how much is there? X cube. Okay. So students, here we can write here what? Sine x square means what we know by the chain rule, cos x square into 2x minus differentiation of x cube. How much is, students, here? 3x square. Is it? So in this way we can do here. Now after that, if we talk about here, students, the second one, we are going to use this one here. Let's take d by dx of we are taking, let's take for example here, x into cos x. How much a cos x? So here we can say the two functions, first function, second function, multiplication is there. So what is this? First function into differentiation of a second function plus second function into differentiation of a first function, is it? Then after that we can use very easily x, differentiation of cos x minus sin x is x, plus cos x and differentiation of x, how much here? 1. Is it, students? So in this way we can do very well how to use the properties of a differentiation. Is it? Great. Now after that, let's see here, we are going to see here some question here. See, first question, calculate instantaneous change of momentum P with respect to time where tangent makes an angle of 30 degree and 60 degree here. Okay, so momentum with respect to time. Time is the independent, momentum is the dependent. So if in case I draw here the graph here, now if I draw here the graph here, so independent here time, and here this momentum is P. Okay, and for some graph is there, let's take some graph is there like this is there. Okay, so what will happen that here, let's take for example, here I have taken point A and I will draw here the tangent is there. Now let's take tangent is there somehow, and here how much angle is there at point A, angle how much, let's take it the 30 degree is there. Okay, similarly if I take another one, let's take somewhere here point B, again let me draw here the tangent like this, tangent like this here, like this here, see, anti-clockwise is going here now, here how much is there, 60 degree. Okay, so if I write here the first one, what they are asking, change of momentum with respect to time. So here P and T is there. So here this is given by dP by dt. What is this? dP by dt. At which point? Point A. How much angle is there? How much angle at point A? 30 degree. Tan 30 degree, how much value? 1 by root 3. Is it? This is the rate of change of momentum of P with respect to T at point A where angle is 30 degree. Second one, at point B. So again now see dP by dt at point B. How much angle? 60 degree. So tan 60 degree, how much coming here? The root 3. Is it? So you can see very well how with the slope, with the concept of slope, we have got the change of momentum with respect to time. Is it? Great. Now after that, one more thing is there. Let's take here. See. Question. Position of an object is given by this one. xt, no, t square plus t minus 1, that means here x as a function of time. Now, calculate instantaneous rate of change of x with respect to t, first part, then later v with respect to t at t equal to 2 seconds. Okay, so we'll do one by one here. See first one. X with respect to t means here, it is given here dx by dt. Okay, and later you will see it will be the instantaneous velocity. So students, this dx by dt is given here d by dt of, put the value of x here, what is this? T square plus t minus 1. Again we will use the property. So just for you I am writing very basic, I am making into the parts, no, like this, d by dt of t minus d by dt of 1. Okay, so here students, as I have told you, what is this? This is the velocity is there. So what this will become here? D by dt of t square means 2t, already we have done. D by dt of t, how much here? 1, and d by dt of constant, how much here? 0. So what we are getting? V equal to 2t plus 1. At which time they are asking? They are asking at t equal to 2 seconds. So at t equal to 2 seconds, put here 2 into 2, let me write here, see. 2 into 2 plus 1. How much coming here? It is coming here 5 meter per second here. This is the first one, x with respect to t. Okay, great. Second one, what they are asking? V with respect to t. That means what this will become here? It will become here the dv by dt. dv by dt. Okay, and we can write here, see, d by dt of what is this? 2t plus 1. Okay, so here what we can write here, see, this d by dt will be 2t and plus d by dt of 1. Okay, after that what will happen that here, see here, the constant and variable both are involved. So constant will come outside, 2 outside, d by dt of t, and differentiation of constant, how much here? 0. So here we can write here, this dv by dt is the acceleration, how much coming here? 2 into d by dt of t, how much here? 2, is it? And anyhow, the unit will be what here? Meter per second square. And here you can see, anywhere this time is involved, no term of time is coming. That means this kind of acceleration where it is independent of time, that is called the uniform acceleration. In physics, it is very important, and all the equations of motion that you have learnt in your 10th and all that. Now, all will be applicable here. What are the equations of motion? You know, v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2s. All these equations of motion applicable when acceleration is the constant independent of time. Okay, great. Now, students, let's see here this question. Somewhat, see, different kind of question, but see, the radius of a circular plate decreases at the rate of 0.1 centimeter per second. At what rate does the area of plate decreases at the instant when r equal to 5 by pi centimeter? Okay. So here, remember that one thing here, what is given here? The decreases. Radius is decreasing. That means the change of the radius with respect to time will be negative. I will write here, see, this dr by dt, the rate of change of radius decreases, that means minus 0.1 centimeter per second. Increases means plus, decreases means minus. After that, what they are asking here? They are asking here the area change. So they are asking dA by dt, how much here? Okay. So after that, what will happen that here? In this, you know, area of the plate anytime, how much is there? A equal to pi r square. Okay. So this is the formula here, anyhow. So if I write here the area, this dA by dt will be what here? See, d by dt of how much coming here? The value of a pi r square. But you know one thing, here r is there, but here t is there. No? It is not matching. So here again we have to just apply one kind of chain rule only. Here I will multiply with dr, here I will divide with dr. Then after that, what will happen that here? This d and this dr we will write together. So what this will become here? See, this d by dr of pi r square into dr by dt. Now, very important formula is coming. After that, you know, pi will come outside, d by dr of r square 2r. That means anyhow it will become here the 2 pi r into dr by dt. Very, very important. See, in case of circle and all, this is a very basic formula. Please remember that dA by dt equal to 2 pi r into dr by dt. Okay. After that, see here, this 2 pi r value, how much given here? See, 5 by pi. Put here please r value at this instant, 5 by pi. And this dr by dt, how much given here? See, minus 0.1. How much coming? Minus 0.1. So here we can see very well, this pi and this pi cancel. 2 into 5, 10, and 10 into 0.1, 1, is it? So if you will solve here, it will come here, see, I'll write here, it will come here minus 1 meter square per second. Now because dA by dt, now here meter square and second. So the area will decrease with the rate of minus 1 meter square per second. Here minus means the area is decreasing. Okay, I hope so this is very clear. Now after that, see the next one. Next one is the somewhat application for the differentiation. See, maxima and minima concept. So see, at the points of maxima or minima, first derivative of y with respect to x becomes 0 as shown in figure is there. Okay. So students, here what will happen that here, see here, just here, this is x, this is y, is it? And after that, see here please, it is given like this. Now one function is there like this. Now this is given like this here. Now after that, students, what will happen that here, see here, this is the point of the maximum and this is the point of the minimum. Here we have to draw here the one line is there, and here also we will draw here one line is there. You know very well here the lines are horizontal. That means you can see very well what are the angles are there. Theta equal to 0 and anyhow theta equal to 0 is there. Okay. So students, here we can see that here if we write here the slope at any point. So this slope is given by dy by dx, is it? So anyhow we can write here the tan theta. Is it tan theta? Theta value how much here anyhow? 0 and 0. Now we have drawn here the horizontal line. So what will happen that here, whenever the maxima or minima will involve, what will happen? This dy by dx will be always how much here, students, here? This will be 0. Okay, remember that here. After that, the conditions of maxima. So if you will see this maxima with respect to the nearby. So maximum at the top and other places the values are less with respect to maxima. So in this situation, what will happen that here, this double derivative, what I am telling, this double derivative, d2y by dx square. What I am telling, this d2y by dx square will be always less than 0. Okay, d2y by dx square always less than 0. Similarly, condition for minima, if you will see here at this point, with respect to minima, other points all are what? High value, more value. So in this situation, what will happen that here, this double derivative, d2y by dx square will be greater than 0. but the question arises, what is the d2y by dx square? Okay, so remember that here students, here I will write here, this d2y by dx square is called the double derivative of y with respect to x. That means d by dx of dy by dx. Okay, double derivative. Is it? So I hope so. This maxima or minima concept is the very clear to you. Remember that. Okay, great. Now students, you can see here one question is there, important. See, divide a number 1000 into two parts such that their product is the maximum. Okay, so students here please, as see here the number is how much here, 1000. Okay, so let's take one part is x, so another part will be how much is there students here, 1000 minus x. Is it? Now students, after that if I talk about here the product is given here, x into 100 minus x, or you can write here, just multiply, see, 100x minus x square. Is it? So after that you know very well, for the p to be maximum, see, for the p to be maximum, okay, students, see, for p to be maximum, what will happen that here, first we will calculate here this dp by dx, this dp by dx should be how much here, 0, p with respect to x, now because x can be anything. So students, you can write here, see, this d by dx of p value how much given here, see, 100x, 100 or 1000, 1000 is there, okay, 1000 is there, put one more 0, 1000 x minus x square, okay, equal to 0. Is it? So students, you can write here, see, 1000x differentiation, so 1000, and the differentiation of x how much, 1, minus d by dx of x square how much is there, 2x, is equal to how much, 0. So if you will simplify this here, you can write here 2x equal to 1000, that means x equal to how much, 1000 by 2, how much coming here, 500, x is coming how much, 500. That means if we write here the values, what are the values? So see here, the first one, x how much coming here, put the value of x, 500, and here 1000 minus x, again how much is there, 500. But the question arises here, maxima also involved, minima also involved. Most of the time, if in the question they are telling maxima, that means this value will be belongs to the maximum. If in the question they are telling minima, then this value will be belongs to the minimum. Second derivative, no need to calculate maximum time. Okay, but anyhow I will just show you this double derivative also. Okay, but no need to calculate in the question. But okay, anyhow I will show you here. See, if I write here, see, this d2p by dx square, double derivative from doing, see, that means here d by dx of dp by dx. Okay, that means here d by dx, is it? And see, dp by dx how much coming is there? See, this dp by dx, what we have got here, this dp by dx was this one, how much was there, 1000 minus 2x. What was there students here, 1000 minus 2x, 1000 minus 2x. So differentiation of 1000 how much is there, let me write here, d by dx of 1000, correct, minus d by dx of 2x. Is it? So when you simplify this, 0 minus 2, differentiation of x is 1. That means how much coming here? Minus 2. And what I have taught you, students, see, whenever the maximum will involve, d2 by dx square will be less than 0. Is it? So anyhow, as it is coming here, minus 2 less than 0, that means anyhow this x equal to 500 will be belonging to which value? Maximum value. Okay, but most of the time no need to calculate it. If in the question they told maxima, answer maxima. If they told minima, no need to check it, always it will be satisfied. Okay student, so I hope so all these things you have understood very well. Thank you so much, take care.